Module 10, Lesson 5 covers the probability of compound events, which means what's the odds of more than one thing happening at the same time. For example, what's the odds of you winning the lottery and then getting eaten by a shark all on the same day? This is what we're talking about with compound events. The suggested pacing guide claims this is going to be a 2-day lesson. There's 15 resources in it, so that's a realistic possibility. When you take a multiple choice quiz, you may have choices to answer A, B, C, or D. The 4 possible answers are the sample space. If there is one question with only one correct answer, you have a 1 in 4 chance, also known as 25%, of choosing the correct answer when just guessing. That's not very good odds, is it? It's always better to study for that test. Suppose there are 2 multiple choice questions, each with answers A, B, C, and D. If both has a single correct answer, how do you think you could find the probability of guessing the correct answer on both of them? That's the kind of things we're going to learn about today, and your answer would be there'd only be a 1 out of 8 chance of you getting them both correct. Now, the textbook is defining a compound event as consisting of 2 or more simple events. Winning the lottery and getting eaten by the shark, that kind of thing. As with simple events, the sample space for the compound event is a set of all the possible outcomes. Rolling a number cube labeled 1 through 6, followed by tossing a coin, is an example of a compound event. The compound event consists of 2 simple events or more. Then this one is going to be the 2 of rolling the cube and tossing the coin. To find the sample space of the compound event, first you must find the sample space for each event. First off, what is the odds of rolling the coin, followed by what are your odds of tossing rolling the dice, followed by the odds of tossing your coin. You can use a table or a tree diagram to find the sample space of this compound event. You can also use an organized list, such as a table, to organize the possible outcomes for rolling the number cube and tossing the coin. So here you can see that the table shows the possible outcomes for tossing them, and we've got on the number cube there's 6 possible outcomes, and if you toss the 1 on the number cube and then you flipped your coin, you could either get a heads or a tails, which would give you a 1 and a heads or a 1 and a tails. If you toss a 2 on a number cube, then you flip your coin, you could get either a heads or a tails on the coin, which would give you a 2 and a heads or a 2 and a tails. Now, looking at it here is kind of confusing, so let's look at it as a tree diagram instead. So I've started off with the coin. I've listed all the possible outcomes of the coin, which are a 1, a 2, a 3, a 4, a 5, and a 6. Now, supposing on that coin we tossed a 1, what are the options on the number cube? Okay, on the coin, the cube, or 1 through 6. And suppose we tossed a 1 on the cube. What are our options on the coin? Well, we could have a head, tails, or we could have our heads. I picked tails first just because I always root for tails. If we toss a 2 on the coin, what are our 2 on the cube? What's our odds for the coin? Well, you could have a tails or you could have a heads. If you tossed a 3, you could still have a tails or a head on the coin. If you tossed a 4, you could have a tails or a head on the coin. If you tossed a 5, you could have a tails or a head. And finally, if you tossed a 6, you could have a tails or a head. This is going to lead us down to the sample space. If you follow 1 tails, that means the first option would be a 1 and a tails. If you followed 1 heads, then you would have a 1 heads. If you did 2 tails, then you'd have a 2 and a tails, or a 2 and a heads, a 3 and a tails, or a 3 and a heads, a 4 and a tails, a 4 and a heads, a 5 and a tails, a 5 and a heads, a 6 and a tails, or a 6, and a heads. And all these things combined are your sample space, a list of all the possible outcomes. Now, if we went back to the textbook and looked at what they had for there, you can see where now you can have 1 heads or 1 tails, 2 heads or 2 tails, 3 heads or 3 tails. The results column here, that is going to be your sample space. Now, if we switch over to the way that the textbook did their tree diagram, they did it sideways, and for some strange reason, they decided to flip their coin first and then worry about their dice. So you can see here, they've got their coin is either a head or a tails. If they flipped a head on the coins, then, let's see if we can get it to move over, you would either get a 1, a 2, a 3, a 4, a 5, or a 6 on the number cube. And if they attached a tail, rolled a tails or flipped a tails on the coin, they would still have either a 1, a 2, a 3, a 4, or 5, or a 6 on the number cube. When you follow that out to the outcomes, also known as the sample space, you get a heads 1, heads 2, heads 3, heads 4, all the way down through the tail 6. These are the same exact answers I came up with mine. They're just written backwards. I did 1 tails and 1 heads. They did heads 1 and tails 1. They're not in the same order, but they are the same exact outcomes, and there's a total of 12 possible outcomes. Regardless of the order of events, your sample space is going to consist of, there it is, 12 possible outcomes. Let's move on to example 1. Suppose a penny and a nickel are tossed. What is the sample space of all the possible outcomes? Well, on the nickel, you can either get a heads or a tails, right? On the penny, that's right, a heads or a tails there as well. So, a couple ways you can do this. You could start off by making a table, and you could see that on the penny right here, they said you would either get a heads or a tails. Regardless of what you get on the penny, your nickel is going to have the same thing going on. If you got a heads on the pennies, that means you could get either a heads or a tails on the nickel. If you got a tails on the penny, that means you could get a heads or a tails on the nickel as well. So if you follow it out, you would have heads, heads, which gives you heads, heads right here. Or you could have heads, tails, which gives you heads, tails right there. You could get a tails, heads, which you see as tails, heads right here. Or you could get a tails, tails, which gives you tails, tails right there. Check your answer. That is one really good way of doing it. Making a table. Your sample space is going to be your results outcome. There's 4 possible results for this problem. Now, if you look at the way they make their tree diagram, it really is very similar to their table. So on their tree diagram, they have their penny and their nickel. So the penny, they could go to a heads on the penny and a heads on the nickel, which gives them a heads, heads. They could go to a heads on the penny and a tails on the nickel, which gives them a heads, tails. They could go to a heads on the tails on the penny and a heads on the nickel, which is going to give them a tails, heads. Or they could get a tails on the penny and a tails on the nickel, which is going to give them a tails, tails. Either way you make it, a table or a tree diagram, you still have the same 4 possible outcomes for this compound probability. Now it's going to be your turn. Pause the video, work extra example 1 on your own. How did that go for you? This table is a little different than the other tables we did, isn't it? A store carries sweaters in green, red, purple, and blue. They're also available in crew neck or V-neck. Drag the items to the appropriate cells to show the sample space of the different options for purchasing a sweater. The first one is completed for you. So here you can see that they got a crew neck and a green sweater. This row is crew necks. This row is V-necks. This column's green, red, purple, and blue. So he could get right here, a crew neck in red. He could get a crew neck in purple and a crew neck in blue. Next, we could do a V-neck in green. We could do a V-neck in red. We could do a V-neck in purple. And we could do a V-neck in blue. Check it, and That's our sample space. There's 8 possible combinations that he could get that sweater, or you could get that sweater. Yep, in this problem. Easy math doesn't get much easier than that. For example 2, a pizza shop sells pizza with a pan or a thin crust, red or white sauce, and toppings of pepperoni, mushrooms, and plain cheese. How many possible outcomes are there in the sample space for a randomly chosen type of pizza? First off, who would put white sauce on a pizza? Ew. Okay, anyhow, how can you start a tree diagram to model a situation? Well, I would personally start it by focusing on the pan. We could either have a pan or thick crust, so we're going to focus on the crust first. Let's take a look and see what they gave. So right here, they said that if you made a pan pizza, then on the pan pizza, you would select either the red or the white sauce. And then if you selected the red sauce, you could have either pepperoni, mushroom, or cheese, which would give you a pan red pepperoni, a pan red mushroom, or a pan red cheese. And then if you did the white sauce, you would have a pan white pepperoni, a pan white, let's try that again, mushroom. And then down here, keep filling in and fall in, you would have a thin red mushroom. So let's do a thin, a red, and a mushroom. And then this one here, fall it out. That means it would be a thin white pepperoni. So we have a thin, a white, and a pepperoni. And the bottom, a thin, a white, and a cheese. A thin, a white, and a cheese. Check it. And it checks. If I zoom out, you'll be able to see right there is your entire table, which could also be seen kind of like a tree diagram. And you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different items in your sample space. 12 different ways that you could arrange these pizzas. Moving forward from here, using the tree diagram is going to work the same basic way. For the tree diagram, our textbook started off with the crust, just like they did for the table, saying you could either get a pan crust or a thin crust. Next, if you got the pan crust, you could have either red or white sauce. If you got the thin crust, you could have either red or white sauce. From here, going to the toppings, no matter which way you did it, you could have either pepperoni, mushroom, or cheese for your toppings. Of those choices, I'd take pepperoni every day, although I'm really a meat lovers fan. Mushrooms, not going to happen. And from there, follow it out to your sample space, also known as your outcomes. You could have a pan with red sauce and pepperoni, a pan with red sauce and mushroom, down here a thin crust with white sauce and cheese. Those are all the possible outcomes. Either way you work it, you're going to get the same 12 different outcomes that you can have. Easy math. Now it's going to be your turn. Stop the video and work on extra example 2. This will be the last thing we're going to do for part 1. Okay, so we have a car dealership, and the colors of a certain brand of car are going to be blue, silver, red, and purple. That's not many choices. Customers can choose a roof as convertible or hardtop. The customers can also choose a manual or an automatic transmission. If a customer randomly selects one car, one roof type, and one transmission, how many possible outcomes are going to be in the sample space? Let's take and work through this. Now, I prefer to do my tree diagrams vertically, to where they did theirs horizontally. I'm going to start off with 4 colors. I've got a blue car, I've got a silver car, I've got a red car, and I've got a, come over the side more, purple car. From here, I've got 2 choices. I can do either convertible or hardtop. Convertible or hardtop. Convertible or hardtop. And convertible or hardtop. I also have a choice between a manual or an automatic transmission. So I could have either manual or automatic, manual or automatic, manual or automatic. And I skipped some of those so you wouldn't have to listen to it. And now it's time to make up my sample space, also known as my outcomes. I could have a blue convertible manual. I could have a blue convertible automatic, a blue convertible, hardtop manual, a blue convertible hardtop automatic, and I skipped some more for you to save you some time, all the way up to a purple hardtop automatic. How many options are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So any way you look at it, there's going to be 16 different outcomes, which is going to be answer D. Check it. And that's going to be it for part 1 of this video. Come back and watch part 2, where I'm really hoping they're going to teach you about the fundamental counting principle. If they do, I promise you're going to like it.